we're ready, then we can, Michael can favor us with a view of the Orion Nebula. All right.
There we go.
There it is. This is a live view.
Well, actually, Mike, you sent me a picture that compressed a shorter exposure in the central part of the nebula that showed the trapezium, actually.
I do have one that I've composited between two different.
Oh, I see how you did it. Okay.
Yeah, it was two different sessions, and I composited them in order to get that.
Okay.
But
Did you do that in Photoshop?
in a Photoshop-like tool, yeah.
Yeah, I was wondering how you did that, because I also took a picture of the Orion Nebula with shorter and shorter exposures until I could only see the trapezium.
I have something called I use a thing called Affinity Photo that I can also use to stack images and also create tiles of astronomical images and things like that. And so I was able to just sort of stack it together there to fix the part where that's blown out. But for a live image, this is what you can. That part's going to get blown.
Did your trapezium show 4 stars?
Well,
be able to see more.
Well, you can't see the trapezium; it's burned out in the center.
Yeah, I can show I can show the composite as opposed to the live image if we like. 1 second.
Yeah, I mention it because once looking through the 20-inch at RC at College of San Mateo, we were actually able to see 6 stars in the trapezium. First and last time ever for me.
This is the one. This is the one with composite, and you can see where the stars are, but they are still they're all blurred together as a big.
Yeah.
Oh, they're overexposed still.
Yep.
Which is the reason for the large airy disks. Yeah. Okay. But I reduced my I'm not. It's not part of my slideshow, but I reduced my exposure down to the point where I could only see just the 4 stars, the 4 main stars. Yes, there are 2 other stars, but they were too faint to show up in my exposure.
Right. Yeah, they were significantly fainter than the other 4. Well, so it's actually 2 Messier objects, M42 and M43, also called NGC 1976 diffuse nebula. It's actually probably the brightest one, the closest and brightest one to us of this type of nebula. And the only possible rival, I guess, is the Lagoon Summer Sky. It's the closest region of massive star formation to Earth, estimated to be 24 light years across, has a mass of about 2,000 times that of the sun. Older texts frequently refer to it as the Great Nebula in Orion or the Great Orion Nebula. One of the most scrutinized and photographed objects in the night sky, and it's among the most intensely studied celestial features. The Orion Nebula contains a very young open cluster known as the trapezium, due to the asterism of its primary 4 stars. 2 of these can be resolved into their component binary systems on nights with good seeing, giving a total of 6 stars. The stars of the trapezium, along with many other stars, are still in their early years. The trapezium is a component of the much larger Orion Nebula cluster, an association of about 2,800 stars within a diameter of 20 light years. 2 million years ago, this cluster may have been the home of the runaway stars AE Aurigae, 53 Ariatis, and Mu Columbii. Sorry if I screwed up the pronunciation on that, which are currently moving away from the nebula at speeds greater than 100 kilometers per second. Just make a further comment on the coloration. Observers have long noted a distinctive greenish tint to the nebula, in addition to regions of red and blue violet. The red hue is the result of the H-alpha recombination line radiation at a wavelength of 656.3 nanometers. The blue-violet coloration is the reflected radiation from the massive O-class stars at the core of the nebula. The green hue was a puzzle for astronomers in the early part of the 20th century because none of the known spectral lines at that time could explain it. There was some speculation that the lines were caused by a new element, and the name nebulium was coined for this mysterious material. With better understanding of atomic physics, however, it was later determined that the green spectrum was caused by a low probability electron transition in doubly ionized oxygen, a so-called forbidden transition. This radiation was all but impossible to reproduce in the lab at the time because it depended on the quiescent and nearly collision-free environment found in the high vacuum of deep space. Okay, do we have another object?
So, Mike,
Show? Yes, sir.
the reflection nebula is in the center of the Orion Nebula, correct? The blue area in the center.
Oh, no, I think it's to the north of the nebula.
Michael, can you put the picture back up?
As I recall, I didn't see any color in the picture that I had on my screen, but that could be because I've lost a lot of my color vision. I see a little reddish.
Yeah, it's
area
mostly red and blue,
between-
bluish gray that you
sort
can
of-
see.
on the M42 side, facing the M43 side, and behind that red patch is where it looks bluish to me.
Right, that's
Yeah.
in the core.
Yeah, a little bit to the right and down. So yeah, I would agree with you. And it's
So
actually just,
the doubly ionized oxygen.
it's actually in the area of the trapezium, it looks to me.
Yeah.
I think the reflection nebula, the pure reflection nebula, is to the north of the Orion Nebula. It's something called the Running Man Nebula.
Yeah, I
Yeah.
got that. That's this one right here.
There was mention of that in the text.
I forget what the NGC number of that was.
I know it is. Well, I have an SH2 number, and then up
Did
by
you
the
take that in your backyard?
yeah, all this is from my backyard. Up above near the belt, there's the horse head,
Yeah.
and a little bit around there, and then up right around that is this one, which I think is spectacular, the Flame Nebula.
Yeah, the flame nebula.
Oh, that's the Flame Nebula, right?
Yeah, that's impressive.
That's a fairly long exposure, I believe, from the EV scope. It's brighter than the rendition that I did.
Does that look brownish to you, or what color?
It's red, but what I got with my light pollution is sort of a burnt orange color. But
Okay, all right.
I have a supernova remnant coming in. It's a little bit blurred out by the moon because it's close to the moon right now.
Okay.
But if you can see this little this patch here that's starting to come in,
Mhm.
that is the Crab Nebula.
M1.
Oh, M1.
M1. Yep, supernova remnant.
Yes, of course. That was the supernova of 1054 AD.
Yeah,
Yep.
otherwise known as the Crab Nebula, which is what I think William Parsons called it. He made a drawing that looked like a crab.
Oh
Yep.
yeah, Lord Ross.
Yeah, this is only about 2 minutes in. So, like I said, it's getting really hurt by the moon because it's really near the moon.
That's
right now.
that's quite good. Usually Crab Nebula surface density is very poor. This is quite easily visible.
But yeah, since with all the stuff that Hanan was talking about, I thought it would be this is live, obviously, and that would be interesting to see the ones that we can see from our backyard.
You know, I believe, I could be wrong, but I seem to recall that the star next to which the Crab Nebula is located is the point of one of the horns of Taurus the bull, and I believe it is the western horn. Could
Yep.
be.
Yeah.
So you can see.
And I
the-
think it's called
Yeah.
Shirnakabti Shashutu.
Yeah.
Yep. Here's
Right.
I put up the diagram of where it is, so you can see the horns of Taurus here, and just exactly as you described.
And at the point of the other horn is El Nath. And El Nath is a star which is exactly the opposite direction of the direction to the center of the galaxy in summer Milky Way. So this El Nath literally points the way directly out of the galaxy, opposite to the center.
Mhm.
This is the Owl Nebula, or M97, which is in Ursa Major.
Ursa Major, yeah, along the base of the Big Dipper.
Yep.
The base of the bowl.
been taking galaxies in Ursa Major recently, so this one sort of came along and for the ride.
Yeah, that's M97, the Owl Nebula.
So that's a planetary nebula.
Mhm.
And
So
then
called because it can turn its head all the way around.
yeah. It says that the Owl Nebula it clears a blue sphere enveloped with a fine red halo, and you can barely see the halo in my picture.
Mhm.
It's about 2,000 light years from Earth and has an apparent diameter of about 3.4 minutes of arc. And so that's about 1.8 light years. It's expanding around 30 kilometers a second. So it's about 8,000 years old.
20 miles a second. That would be, let's see, 3,600 seconds in an hour. So about 72,000 miles an hour, if I did that right.
Yeah. Oh, I think it's kilometers. I think I meant to say 30 kilometers a second. I might have said
And
miles.
I
but-
translated that to about 20 miles a second.
So anyway, that's a couple of the remnants left from of the life cycle of stars.
Yes, you're quite right. I've been looking up the owl, and they say also 8,000 years old, approximately circular in cross section, a little visible internal structure. It was formed from the outflow of material from the stellar wind of the central star as it evolved along the asymptotic giant branch. No, that's reference to Hanan and the HR diagram, I guess. The nebula is arranged in 3 concentric shells, with the outermost shell being about 20 to 30% larger than the inner. The owl-like appearance is the result of the inner shell that is not circularly symmetric, but instead forms a barrel-like structure aligned at an angle of 45 degrees to the line of sight. Have to see if the next owl I see looks that way too. It holds about 13/100ths of a solar mass of matter, including hydrogen, helium, nitrogen, oxygen, and sulfur, all with a density of less than 100 particles per cubic centimeter. Its outer radius is about 0.91 light years and is expanding with velocities in the range of, as you said, 27 to 39 kilometers per second into the surrounding interstellar medium. 14th magnitude central star has reached the turning point of its evolution, where it condenses to form a white dwarf. It has 55 to 60% of the sun's mass, and about 41 to 148 times the brightness of the sun, and an effective temperature of 123,000 degrees Kelvin. The star has been successfully resolved by the Spitzer Space Telescope as a point source that does not show the infrared excess characteristic of a circumstellar disk. Not sure I follow that. Okay, that's all I've got on that.
Do you have access to the planet Uranus?
I have a previous one of it if you really want to see it somewhere. It's a very pale blue dot.
So it should look like something like a green dot. Huh?
Yeah, pretty much. It's nothing spectacular like Hanan gives you.
Actually, it kind of looks like a planetary nebula in some ways.
Yeah.
That's Uranus as I can get it.
Yeah.
So.
Yeah, that's about right. Yeah.
I do have one other little bit, I think, because Ken alluded to it as well, and it's part of his story. I have a picture of a supernova. This was one that was not too long ago.
Mhm.
And the little blue area right here, it's here's the core of the galaxy. This galaxy is pretty far away. But over off on the arm, you'll see a really bright blue. That's a type 1A supernova.
Which galaxy is this?
This is the one that you mentioned.
Oh, 514.
Yep, 514. Yep.
Right. Yeah, there's a star just above it, and it's fairly faint, right?
Yep.
Which constellation is that?
Cetus, I believe.
Yeah.
Oh, so it's an NGC?
Yeah, it's
Right.
NGC 0514.
Yeah, 0514.
That was what, in October? There's another
right.
one that just
Yeah.
went off, which is 4414. I've been trying to get that one, but it doesn't rise until really late. Do have a live shot of Bode's galaxy starting to come in if we want to take a peek.
M81,
Okay, M81.
Yeah.
also known as NGC 3031 or Bode's galaxy. It's a grand design spiral galaxy about 12 million light years away. It's about 6 times the Andromeda, or 5 times, with a diameter of 90,000 light years. Makes it a little smaller than ours. In the constellation Ursa Major. Due to its proximity to Earth, large size, and active galactic nucleus, which harbors a 70 million solar mass supermassive black hole. Messier 81 has been studied extensively by professional astronomers. The galaxy's large size and relatively high brightness also makes it a popular target for amateur astronomers. First discovered by Johann Elert Bode on December 31st, 1774. So it's sometimes called Bode's galaxy. 1779, Pierre Méchain and Charles Messier re-identified Bode's object, which was subsequently listed in Messier's catalog. It's located approximately 10 degrees northwest of Alpha Ursa Majoris, along with several other galaxies in the Messier 81 group. Messier 81 and 82 can both be viewed easily using binoculars and small telescopes. They're generally not observable to the unaided eye, though highly experienced amateur astronomers may be able to see 81 under exceptional observing conditions with a very dark sky. Telescopes with apertures of 8 inches or more are needed to distinguish structures in the galaxy. Its far northern declination makes it generally visible for observers in the northern hemisphere, so it's not visible to observers in the southern, except those in a narrow latitude range immediately south of the equator. Yeah, and it's
Yeah,
it
I've been
presents well for the spiral structure.
yeah, you can sort of start to see the arm, one of the arms coming off here. There's another one up here.
Yeah.
It's gonna take a lot longer for it to come in before you could really make some of that
How
out.
long was that exposure?
It's active live, so we've seen it. It's about
Oh, okay.
right now. So this is a live shot. I have an hour-long shot already done, but I'm doing live. So
So M82, the Cigar Galaxy, also
Yeah.
NGC 3034, is a starburst galaxy about 12 million light years distance. Again, in Ursa Major, a member of the M81 group. It's about 5 times more luminous than the whole Milky Way, and has a center 100 times more luminous than our galaxy's center. Starburst activity is thought to have been triggered by interaction with neighboring galaxy M81. As the closest starburst galaxy to Earth, M82 is the prototypical example of this galaxy type. SN 2014J, a Type 1A supernova, was discovered in the galaxy on 21 January 2014. Scientists discovered the brightest pulsar known, designated M82 X2. It was also discovered by Bode on 31 December 1774, together with M81. He described it as a nebulous patch about 3/4 of a degree away from M81, very pale, of elongated shape. In 1779, Pierre Méchain independently rediscovered both galaxies and reported them to Charles Messier, who added them to his catalog. Yep, that's a very nice picture.
Mhm.
Boy, good definition. I like that. Yeah, Messier 108, also NGC 3556, is a barred spiral galaxy in the same constellation, discovered by Pierre Méchain in 1781 or 82. From Earth's perspective, this galaxy is seen almost edge on. Is that 108 we're
that is
looking
it.
at?
That's 108.
The
Oh,
galaxy,
that's near M97, I believe.
Yep.
yeah, well,
Yeah.
they're
it is.
all in Ursa Major.
Right.
This galaxy is an isolated member of the cluster of galaxies in the Virgo supercluster, the Ursa Major cluster of galaxies in the Virgo supercluster. It has a morphology classification of type SBBC in the Devaucouleur system, which means it's a barred spiral galaxy with somewhat loosely wound arms. The maximum angular size of the galaxy in the optical band is 11.1 minutes by 4.6 minutes, and it's inclined 75 degrees to the line of sight. The galaxy has an estimated mass of 125 billion times the mass of the sun, and includes about 290, give or take 80 globular clusters. Well, it's about twice the number we have. Examination of the distribution of neutral hydrogen in this galaxy shows shells of expanding gas extending for several kiloparsecs, known as H1 supershells. These may be driven by bursts of star formation activity, resulting in supernovae explosions. Alternatively, they may result from an infall of gas from outside the galaxy or by radio jets. Observations with the Chandra X-ray Observatory have identified 83 X-ray sources, including sources located at the nucleus. The brightest may be an intermediate mass black hole that is accreting matter. The galaxy is also emitting a diffuse soft X radiation within 10 kiloparsecs of the optical galaxy. The spectrum of the X-ray source at the core is consistent with an active galactic nucleus, but an examination with the Spitzer Space Telescope shows no indication of activity. The supermassive black hole at the core has an estimated mass equal to 24 million times the mass of the Sun. Messier 109, discovered by Pierre Méchain in 1781. In 1783, Charles Messier cataloged NGC 3992 as his 109th object. Well, that was practically the last one he got. Between the 1920s through the 1950s, it was considered that Messier objects over 103 were not official, but in later years, the additions became more widely accepted. David H. Levy mentions the modern 110 object catalog, while Sir Patrick Moore gave the original to 104, but has M105 through M109 listed as an addendum. By the late 1970s, all 110 objects are commonly used among astronomers as they were commonly used among astronomers as they still are today.
There's something I found with this picture that I haven't been able to identify yet, as there appears to be a background galaxy or a dwarf galaxy over here, and then another one down here.
Yeah.
But I haven't been able to identify what they are yet. I ran them through a tool I use, but it didn't pick them up. So I don't know what they are, if they're a background galaxy or a dwarf galaxy, but sort of showed up. So kind of interesting.
They say there's a supernova 1956A observed in M109. Was a type 1A supernova in the southeast part of the galaxy, glowing at magnitude 12.8 to 12.3 at its maximum. It has been the only supernova observed in M109 since its discovery. It's also by far the most distant object in the Messier catalog, followed by M91. M109 has 3 satellite galaxies, UGC 6923, 6940, and 6969, and possibly might have more. Detailed hydrogen line observations have been obtained from M109 and its satellites. M109's H1 distribution is regular with a low-level radial extension outside the stellar disk, while at exactly the region of the bar, there is a central H1 hole in the gas distribution. Possibly the gas has been transported inwards by the bar, and because of the emptiness of the hole, no large accretion events can have happened in the recent past.
Yeah, that astronomer I was talking about, one of the reasons she's studying bar galaxies is because of the way the bar galaxies suck the gas into the center, and that can cause the quenching to where things don't make stars. So some bar, this is sort of still theory and stuff she's working on. That this may be a way that quenching happens is actually through bar galaxies where the gas is all being driven to the center. It gets to the center, it actually gets heated up. And once it gets heated up, you can no longer make stars.
Yeah, no cold gas. M109 is the brightest galaxy in the M109 group, a large group of galaxies located in the constellation Ursa Major that may contain over 50 galaxies.
5 M82. Just to keeping it real here. I just love the little split in between it, between the 2 lobes.
Great detail, yeah.
Are there 2 lobes, or is that's a dust lane, isn't it?
Yeah, it's a dust lane. It's not really 2 lobes, but it looks like 2 lobes because of the dust lane. Supposedly there's stuff being accreted out. If you could look at it in different wavelengths of light, you see like jets flying out of it. I guess it's from the black hole.
Well, that's what M82 is famous for.
Those would be X-ray.
Is the jets.
Yep.
Jets.
Yeah. Now I gotta wait for Unistellar to come out with cameras that can look at X-ray and.
Hopefully you can see this. This is a picture I took I think about a month and a half ago.
Yeah.
Of NGC 891.
That's one of my favorites. That's so clear, so clear.
And that was taken with the 5-inch AP refractors. So it's actually not a lot of magnification that it can produce, but it still came up pretty nice.
Boy,
and
that's beautiful.
When you look at the wide field view, which is even cooler, this is the wide field view, and you can see obviously the galaxy here in the center.
Yeah.
And I suddenly noticed that there's a bunch of little edge-on and face-on galaxies all over the space. And so I did a little research because I wasn't really sure what I was imaging. This was my target, and clearly it's in the middle of the field of view, but then all these other little galaxies were showing up everywhere.
See that?
So I did a little research, and basically, this is NGC 891. This galaxy group is called Abell 347.
Huh.
And these are galaxies that are located about half a billion light years away.
Wow.
So this is probably one of the deepest space images I've ever taken, and
Yeah.
really a really old light. You can see here.
This is
This
the
is a
the Hanan deep field, sort of like the Hubble.
Yeah, well, they went 13 billion years deep. I only went half a billion years deep. But on the other hand, I didn't spend billions of dollars on a space telescope.
Right.
So so you can see here, this is a close-up of that region, and NGC now 891 is up in the upper right corner. And I was able to find the names of all those galaxies that are circled and highlight them. So it was a really cool exercise of had to do a lot of research to try and identify which galaxy was which.
Yeah.
It was a lot of fun, and I'm
There's
not
a
exact-
there's a website that I'll send you that you can upload your images in, and it will process them. And a lot of times it'll identify those hard ones. That's usually what I use when I can't figure it out. I'll send you the link to it. It might help you. It like I said, it didn't help me all the time, but a lot of times it really works. So
Gives you a
yeah,
lot of
so sorry. By the way, I was wrong. It's quarter of a billion. So NGC 891 is
well, that's just a stone's throw.
exactly. So NGC 891 is 30 million light years away, and those galaxies are 240 million light years away. That's still pretty
Yeah.
cool.
Okay, so I decided to go for a few star clusters to start with. I went for the ones in Auriga, which are M36, M37, M38. Here's M36 at any rate, which is, was it discovered by Giambattista Hodierna before 1654. That's pretty early and pretty primitive telescopes at that time. But Messier reobserved it in 1764, and it's about 4,340 light years away. So that's one of the three major star clusters in Auriga. And the other one here, this is M37, and that was also discovered by Hodierna before 1654, but then reobserved by Messier in 1764. It's 4,500 light years away, so it's a pretty similar distance. And then this one is actually M35. So this is M35 at the foot of Gemini. And right next to it is actually a little star cluster called the NGC 2158. And this is much further away, which is the reason why it looks smaller. It's whereas 35 is 3,870 light years away. 2158 is about 12,000 light years away. They're actually quite close together in the angular distance, but I didn't bother to try and take both of them together in the single field. So I found a one on the internet which shows actually how close they are to each other. And they're literally right next to each other. So next time I take a look at them 35, maybe I'll try and take a shot at shooting them in the single field of view in the EV scope. Now the EV scope has a field of view about half a degree, which is about the size of the full moon. So I probably could get the two of them together in one of my fields. Okay, let me see. What's next?
35 the one in the middle on this?
The 35 is the big one to the left
One on
of the center, and the one to the right of center is the more distant cluster, 2158 at about 12,000 light years.
That's the linear one, the one that looks like a string through the center.
Yeah, it kind of has a string of stars going through the center, adjacent to it. All right. Now I started exploring some galaxies in Eridanus. There's a whole cluster of galaxies there, and I picked out a few that I thought would be interesting. This is NGC 1187 about 60 million light years away. It's a barred spiral. I found that I could see more detail if I simply magnified up the images. And so this is what the EV scope can show, maybe after about 10 minutes of exposure. Actually, it's not too bad, considering it's a tiny little 4-inch telescope. I was able to find an internet shot of it, and this is what the more glorious view of the thing
yeah.
looks like. So you can see it's a big barred spiral. It's what's called an intermediate barred spiral. In other words, the bar isn't a huge part of its structure, but on the other hand, it's still recognizably there.
Yeah.
Okay, right.
Is that a Hubble image?
I don't know where this came from, actually. Maybe if I exited. Oh, this is from the European Southern Observatory. So it's probably from one of their big
Okay.
eight
ground-based.
meter telescopes. Yeah. Right.
Chile, probably Chile.
Right. It's down in Chile. Right. So it's a ground-based image. Let's see. Then this is another spiral. This is NGC 1232. And if you can see off to the left here, there's a little smudge right here. Okay. And I took a magnified image of this. So with the EV scope, I can actually bring out quite a lot of the spiral structure of this galaxy. So even though it's not as definitive, it looks like this galaxy has lots of spiral arms, actually. And you can see
I think if you would have let it sit like for 45 minutes, you'd be
Yeah.
blown away. What you
Yeah, I
could,
probably see more, but I wasn't willing to long exposures
yeah.
at this time.
I for a while I thought it didn't ever get better than after 15 minutes, but I have found that is not true. And
Yeah, you can
sit
see a
on-
lot more detail on these things if you magnify the image, and so if you take a long exposure and then magnify the image, I'm sure that you'll
yeah,
get a very
yeah,
impressive result.
you ought to revisit this and sit on it. I think that looks really interesting.
Yeah, that looks really. And there's a little satellite galaxy off to the left, as you can see there. And to show it in its glorious best, this is actually what it really looks like.
Okay.
And it's one of the galaxies that seems to have the largest number of spiral arms I think I've ever seen. I mean, this is amazing.
The
It's some 8 spiral arms, which
Oh.
makes it look like an octopus, actually.
Yeah, the octopus.
And the galaxy off to the left that we saw a little smudge about turns out it turns out to be actually a satellite galaxy rather than just a galaxy that is in line of sight and more distant, because the estimated distances to both of these galaxies is a little over 65 million light years, actually. And so it turns out that's a small satellite galaxy off to the left.
What was the name of this octopus?
It's NGC 1232, and the other one to the left is 1232A.
Oh, yes. Okay. I remember you mentioning that in your.
Right, exactly.
Um,
Okay, and there's a small hint of a bar in the middle, but not much of it. It's mostly a grand design spiral, but with an exceptionally large number of spiral arms. And so this is what the EV scope could do with this.
Mhm.
I can probably get more of an exposure if I let it run for an hour, but I just wasn't willing to go that far on it. Okay. All right, this is a planetary nebula. This in Eridanus. This is NGC 1535. You can see the green color on it from the forbidden lines of excitation from ionized, rarefied ionized oxygen. So when you mentioned that the emission lines from objects like this were initially not associated with any kind of ground-based elements that people knew about at
Yeah,
the time.
that was what they hypothesized was nebulium.
That's correct. They thought they had discovered a new element, but later on, it was in the 1920s. It was Henry Norris Russell who proposed that it was actually coming from unusual and rare transitions in oxygen that occurred only in when the gas is extremely rarefied. I'm not exactly sure how rarefied. I haven't looked that up yet, but it's an indication that the density of the gas in the nebula is actually quite low. So that's an interesting physical indication in the. Anyway, here's a close-up view of that same planetary taken by Adam Block through his 20-inch down at Mount Lemmon. And so here you have an opportunity to see the internal structure of this planetary.
Where's Mount?
Okay.
That I
Mount Lemmon is in southern Arizona. It's near Kitt Peak.
Oh, okay.
Okay, and the Adam Block has been a long time associated with Kitt Peak. He used to run an astrophotography program for the general public down there. People would show up, pay their money, and have access to his 20-inch, and they would bring their laptop or something like that, plug it in, and download images taken through his telescope. That was how he ran things. I don't know that he's doing that anymore. I think they closed down most of Kitt Peak at the present time, so I don't think the observatory is open any longer. This is a globular cluster. It's a M79 in Lepus, just south of the Orion constellation. And it's the only really big globular cluster that I know of in Lepus. I don't have telescopes quite this big, but this is a close-up view of that globular cluster. Interesting thing about this globular cluster is that it is not thought to be actually part of the Milky Way. It is, there is some debate about this, but it is thought to be at its distance of 42,000 light years, which is about a third of the diameter of the Milky Way galaxy. At a distance of 42,000 light years, it's thought to be part of a mostly invisible dwarf galaxy called the Canis Major dwarf galaxy. It's not truly an intergalactic tramp, is what they had nicknamed some of these things, which is the globular clusters that are so far away they're basically wandering around intergalactic space from one galaxy to another practically, but it is thought to be associated with the dwarf galaxy rather than with the Milky Way.
There is one globular cluster which is located about 300,000 light years away, or even more than that. It's a good like 10% of the distance towards Andromeda, and it doesn't seem to be associated with anything, which is just weird.
I've heard about
Really
it. Yeah,
weird.
right. I think that was the globular that acquired the name of intergalactic tramp when it was originally discovered. I think it's Palomar something, I think. There's also if you look in the upper right, there's a line going through there. Looks like from a satellite. And I don't know if from a Starlink satellite or not. This is NGC 1784, also in Lepus. It's a barred galaxy 100 million light years away. This is acquired now with a little 4-inch telescope. So this is the magnified view of it. And this is what the EV scope can do. So if I had a longer exposure, I might be able to see more. And this is the barred spiral taken again with Adam Block's 20-inch down to Mount Lemmon. So the EV scope can actually do pretty good for a 4-inch. Wow, that's pretty amazing. You can see
very impressive.
Have a pretty impressive detail, considering that you can acquire it all with such a small telescope.
Yeah.
But this is the more detailed view from a 20-inch. And then finally, this is a view of 1832, also in Lepus. Okay, this is just a classic spiral galaxy. The reason why this is of interest is because there were a couple of supernovae that were associated with it, I think from 1992 and another one in 2007. This is a picture taken from the Sloan Digital Sky Survey of the same galaxy. Oh yeah, this is a supernova from 2009. That was the significance of this galaxy that had a supernova near it. Okay, so you can see the bright star off to the left, and also to the left on this EV scope view. And then in 2009, there was a supernova just below the galaxy. Okay, this is an interesting galaxy. This is a NGC 1888, and it looks like there's a star that's next to the galaxy in line of sight. But here's the magnified view of that thing. But it turns out that's a dwarf elliptical galaxy, which is NGC 1889, which is a satellite galaxy of the spiral. It's kind of similar relationship to the spiral galaxy, as the dwarf elliptical galaxy M32 is related to M31. So this thing is what is it? A large telescope view showing the dwarf elliptical and the spiral next to it. Okay, so I think that's all I have to show.
Ask Mike, are you still live?
Yeah, my scope's still up.
So can I ask you a favor? Can you try and see if you can point to Messier 46, M46? So this one, I'm really interested in seeing what the EV scope will do, because it's a really interesting combo. It's an open cluster. That's the object. M46 is an open cluster. Right smack in the middle of that cluster is a planetary nebula, kind of a mini.
Oh, there's a ring. Yeah, the smoke ring.
Yeah.
Okay, so it's up. I can actually almost already see the smoke ring. So let me.
Wow. Okay.
There it is.
Oh wow, that's M46, isn't it?
Yeah, that is
M46
M46,
and
and you can easily see the planetary nebula. There it is.
Yep.
Yeah, there it
That's
is.
only after that's 30 seconds.
That is pretty fantastic.
That's a pretty bright the planetary.
Yeah, and it's even has a trace of color to it. You can make out a little bit of color in the
Yep.
planetary.
Well, I think if I give it time, I mean, like I said, this isn't even a minute.
Yeah,
The color will show. So if I leave it here 15 minutes, I bet we get color. So obviously nobody wants to wait that long, but
yeah. No, but it's a really nice, being able to handle the obviously very bright stars of the cluster and the dimness of the nebula, and it's still picking it up quite nicely. It's handling the contrast really nice.